Hey class, I'm super sorry I couldn't be there with you today, but you know the reason that I'm not. Hey, go ahead and read the 4 learning targets at the top of this page, and not really gonna do it with you. I'm gonna keep telling you to pause, let you try it first, and then you'll be able to check your answers with me. So this first video is just gonna be the front of this page. There'll be a totally separate video for the back. So go ahead and read those learning targets to yourself. If you need to, pause the video, because those 4 are exactly what you're about to learn today. Go ahead. Okay, if you pause the video, you also just watched the video about the Plano Balloon Festival. Your substitute teacher just showed it to you. That was so that it could give you an idea of what you're about to talk about here. Okay, go ahead and read this statement silently to yourself. Pause the video. Okay, if you read that statement, then grab your highlighter. At this point, you being that brilliant mathematician that you are, you should already be able to start identifying slopes and y-intercepts from word problems. So I hope that when you read that, this stood out to you immediately. Altitude of 400 feet. Highlight that. Label that either the slope or the y-intercept. You do it first, see if you get it right. You are correct if you said that the altitude of 400 feet represents our y-intercept. We know this because that's the starting place. That's where the balloon starts in this situation. 400 feet is our y-intercept. Okay, next, you should be able to see the rate of change, the coefficient, the slope in this word problem. If you saw it, then yes, it's going to be right here, 20 feet per minute. Annotate that. You could call it the coefficient, you call it the rate of change. I'm going to call it slope, since I'm about to create, apparently, a graph from it. There's one more thing missing, though. Is my slope going to be negative or positive? See if you can figure out the answer based on this word problem. The answer is negative. Find the word in the word problem that told you this was a negative slope. Good. Descending. It's descending at that rate, so I need to annotate that. This is going to give me a negative slope. Good. We're highlighting, marking, and annotating the text. Okay, I want you to go ahead and use this information you just found, y-intercept and the rate of change, the slope, to fill out this table. Pause this video, fill out this table, and let's see if you get it correct. Okay, if you did it correctly, then here's what your table should show. I'm trying to hide my graph here. Here is my table of values. I did the first few for you to show you how I got these answers, so here's what I did. I saw that my starting value, y-intercept, was 400. That took no work. But then it's decreasing, it's descending 20 feet per minute. Here's my proof. It starts at 400. 2 minutes later, it's gone down 20 feet per minute. That means 20 times 2 is 40. I took that away from 400, and that got me 360. Did the same thing here, but now it's been 4 minutes, so 20 feet per minute after 4 minutes means I've descended 80 feet from 400. 400 minus 80 is 320. I did it again. It's been 6 minutes. 20 feet per minute for 6 minutes means it's descended 120 feet. 400 minus 120, 280 feet. I could keep going that way, or I could be a mathematician and look for a pattern. 40, 360, 320, 280. You should be able to see, oh, each of these are increasing by 2 minutes. And as that's happening, each of my altitudes are decreasing by 40 feet. So I was able to complete my table without continuing to write these expressions. Good. Now I want you to take that information and complete the graph. That's what the directions say. Table, check. Now complete the graph. Pause the video to see if you get it correct. Good. If you just unpause, that means your graph is done. Make sure you followed the directions. Make sure you labeled your axes. If you didn't, pause the video again and label your axes. All right, if you did that correctly, Here's the graph. I'm sorry about the mistake. I didn't want to use whiteout. Here's what your graph should look like. Okay, let's go back to 6th grade for just a moment. Decide whether or not we should connect these points. If you remember, in 6th grade, we determined the only way you would connect these points is if it makes sense to have fractions for each of our labels. We'll stop and think. Does it make sense to have 100.5 feet? Sure, you can have half of a foot. Does it make sense to have 3/10 of a minute? If this is 1 right here, then if I connect those points, that means I can have a value right here. You see what that pin is? That's half of a minute. Does it make sense to have half of a minute? Well, sure, absolutely. That's the reason you should connect those points. So grab something straight, grab your interactive notebook, your calculator, find something that has a straight edge so that you have a nice, neat graph here. Good. I connected the points from the table, which is why I stopped right here. I didn't connect that point. You can. It does continue, but I just wanted to use what was in the table. All right, here we go. Grab your highlighter. Next to letter A, please go ahead and highlight the word situation. Now letter A looks like this. I would like for you to pause this video and answer questions A through C. I repeat, A through C. When you're done with A through C, press play and we'll check your answers. All right, let's see how you did. Question A, what information does the situation describe? How does it describe the altitude and how it's changing? Well, my situation told me how the altitude is changing because of this word, descending. Descending told me is a negative. It also told me 20 feet per minute. B, you should have highlighted graph. Underline rate of change. How can I determine the rate of change from a graph? Well, that means if all I give you is that, and I say, hey, mathematician, tell me the rate of change, you would do rise over run, which means slope. Rise over run, down 40 over 2. Here's my proof. I can pick any points I want on this graph. If I pick this point and I go here to here, that was down 40, negative 40. And then my run, I'm moving to the right, that's a positive, positive 2. My slope, therefore, is negative 40 over 2, which simplifies to negative 20 over 1, which simplifies to negative 20. Letter C, you should have highlighted table. How can I find that same rate of change, this same number, if I don't give you the graph, if all you have is a table? Well, that's where you grab your highlighter and you pick 2 y values. I picked 120 and 160. Whichever 2 that you picked, highlight them. Now you need to use the corresponding x values. And all you're going to do is calculate the change. I'm going in this direction. I'm going to do 120 minus 160, which means I can't flip it and suddenly do 12 minus 14. I need to go in the same direction, 14 minus 12. Here's my work. Here's how I got it. 120 minus 160 over 14 minus 12. Remember that these buttons in your calculator will do that for you. Alpha, y equals, and then 1. If you put this into your calculator, it'll get you straight to negative 20. Good. Pause this video again because I want you to do D, E, and F. D, E, F. Press play when you're done with those 3. All right, let's see how you did. Letter D, what's the starting point? The starting point is where the hot air balloon began in this situation. That's going to be 400 feet. How do you describe that location on a graph? That means I need the coordinates of the y-intercept, 0, 400. Letter E, write an equation in slope-intercept form. I'm so sorry. Please forgive me. I should have highlighted starting point. Letter E, it's obvious. I should be highlighting equation. Here's what I know about equations. Y equals mx plus b. Well, in my situation, I know that m is my slope. There it is. I know that b is my y-intercept. There it is. So writing that as an equation, y equals negative 20x plus 400. F, what does the x-intercept of the graph mean? Please highlight x-intercept. I understand that you have not learned about x-intercept, but it's so obvious if you just use the name. X-intercept. That means where your graph intersects the x-axis. Well, if I continue this line now you can see why I didn't before. Look at where it intersects that x-axis. They're asking, what would that mean? Not, what's the location? Well, if this graph shows the balloon descending, then when it gets here, that altitude is 0. You can't go any further than the ground. So that would mean the altitude is 0. The balloon touches the ground, hits the ground, reaches the ground. Good. Okay, let's do this one together. What is the altitude at 7 minutes? Well, look at your table. Do you see 7 minutes? Me either. But I'll give you 10 seconds to figure out what the altitude would be at 7 minutes. 5 seconds. All right, let's see how you did. If 6 minutes is 280, 8 minutes is 240, then I can be a mathematician, use that pattern, and find what would be right here in between. 6 minutes is 280, 8 minutes is 240, which means I could squeeze right in here in this table. 7 minutes would be halfway between 240 and 280. Well, I just think of these as 24 and 28. Halfway between 24 and 28 is 26. So halfway between those two would be 260. 260 feet. All right, let's wrap this up. Slope-intercept form, y equals mx plus b, where m is your slope and b is your y-intercept. You're done with this video. I'd like you to go ahead and start on the back of this page, and after you get about halfway through, then pull up this second video because I'm going to go ahead and have the answers ready to show you.